Okay, so far we've been looking at complex numbers, and really we've been looking at the arithmetic. How do you add, how do you subtract, how do you divide, how do you multiply, and just working with these numbers, changing them to polar, that sort of thing. How to plot them on the Argand diagram. It's all about the numbers. But what we're going to start covering now is the algebra, which is probably a bit more important. Covering the algebra, in other words, factorizing expressions, complex expressions, and also solving equations. Okay, so that's what we're doing now, and the best way to do it is just to start by an example, and I'm just going to do it two different ways. One is perhaps simpler than the other, but I'll just do it both ways anyway. So if you've got a simple quadratic like this, nice and easy, an easy way to do it is just to move the 9 onto the other side, so equals -9. And so therefore take the square root of both sides, so the square root of -9, and of course whenever you take the square root you get a plus and a minus, and then we get plus or minus, the square root of 9 is 3, and we get an I in there because of the -1 that's in there. So there's your solutions, plus or minus 3i. Now the other way to do it is like this, and it might seem a bit stupid, but stay with me. So if I rewrite this as z squared minus -9 equals 0, and the reason I did that is because I want to have the difference of perfect squares. So difference, because it has to be minus, I'll get the difference of z squared, and something squared is -9. Okay, so when we factorize this, we factorize it into two brackets, and we put the square root of each of these in there, as you already know. So the z's will go there, that's the square root of that, and what's the square root of -9? Well, it's 3i. So we put 3 i's there, because it's difference of perfect squared, one's plus and one's minus. And therefore we get z's equal to -3i and positive 3i. So there's your two solutions. So exactly the same. This way though has used factorization. So it's used this factorization process to be able to get the solutions. This one over here just uses rearranging an equation to get the answer. It's just important to get used to both of these procedures, because one of them will sometimes be better than the other, and sometimes a question in an exam or something will ask you to do that. But let's have a look at something a bit better than that, because that's generally a pretty sort of simple problem. Let's have a look at z squared plus 3z plus 3 is equal to 0. Okay, so here we have a quadratic, and it's a bit more complicated than the last. How could we solve for z? And just a point here, in complex we generally will use z, just like in real number system generally we use x as the variable, just generally z tends to be in complex. So let's have a look at this. If you had this in the real number system, how would you solve it? Well, you'd probably use the quadratic formula, and the quadratic formula still works in the complex system. So let's do that. So I'll do it two ways. So just remembering what we've got here. So using the quadratic formula, okay, so z is equal to -b, so b is equal to 3 in this case, so -3 plus or minus the square root of b squared, so that's 3 squared, so that's 9, minus 4. What's a in this case? It's 1, and what's c? It's 3. Okay, and that's all over 2a, and a is equal to 1, so that's just 2 there. So we continue. Let's just simplify that. -3 plus or minus, here we have 9 minus 12, so that is -3 over 2, and basically now we can rewrite this down. Negative plus or minus, that is the square root of 3i over 2. And if you wanted to write that a bit different, you could go -3 over 2 plus or minus √3 over 2i, something like that. Okay, so that's the first way to do it, using the quadratic formula. If you're asked to factorize a quadratic before solving it, then you'll have to complete the square. Okay, so I'm just going to do the same thing but complete the square. Okay, I might run out of space. Would you mind if I'll go to the next page if that's okay with everyone. So I'll just do the same one, and we'll just have, what did I have? Z squared plus 3z plus 3. So let's have a look at that. Let's complete the square. Equals 0. Therefore, haven't got a number in front of the z squared, that's nice, and so what we'll have z squared plus 3z. Now remember, completing the square, we divide this number by 2 and we square it. So 3 over 2 and square it is going to be 9 over 4. Great, so we've got that. And now we've added this 9 over 4, so we've got to subtract the 9 over 4, and we've still got that plus 3 sitting there. Okay, great. This simplifies down to z plus. Remember, then when this comes down, the b comes down to, you divide it by 2 and square it. That's what all that bracket is equal to. And what do we have left over here? Let's do it the slow way. 9 over 4. What's 3 over 4? Well, that'll be 12 over 4. Okay, and just in case I run out of space, z plus 3 over 2 squared, and we've got negative 9 over 4 plus 12 over 4. That will be plus 3/4 equals 0. Great. So we have completed the square here. Alright, but we're not done yet. We haven't even factorized it yet. Now I'll do it again the slow way. So z plus 3 over 2 squared. Now what I'm going to write this is, just like before, I'm going to write this as negative, so minus negative 3/4. Okay, so I'm just going to write it like that, because then I can look at what the difference of perfect squares is. Okay, so let's do exactly what we did before. I'm going to do it in some big brackets, so I'm not making any mistakes. What's the first term we have squared? It's z plus 3 over 2. Z plus 3 over 2. And what's the square root? What's the square root of this in here? So what we've got, we'll have the square root of 3 over 2, so that's the square root of this, but because it's got a negative, when we do the square root, we're going to get this I there, okay? And it'll be the same here, root 3 over 2I, because we're square rooting that. Just to remind you, if you've got z squared minus 16, what does that factorise down to? It goes z minus 4, z plus 4. And so we're taking the square root of each of those. The square root of negative 3/4 is root 3 on 2I. And difference perfect here, we've got a plus and we've got a minus. Now this is factorised, and what we're going to do is take our solutions from there. So therefore either z plus 3 over 2 plus root 3 on 2I equals 0, or z plus 3 over 2 minus root 3 on 2I equals 0. You don't need to write that step. Therefore, but I'm just showing you, z is equal to, if you solve for them, is negative 3 over 2 plus or minus root 3 over 2I. And there's your two solutions there. So, and that's how you would solve, that's how you would solve this equation, by completing the square. And sometimes it'll just ask you to solve it, and so you can use the quadratic formula. That's fine. Sometimes the question will ask you to solve it by completing the square or by factorising, and you'll need to be able to use this method. And basically, that's how you use, that's how you factorise and solve quadratic expressions.